Hi everyone, welcome back to my videos. Uh, I want to go over some techniques how to prove that some kinds of quadrilaterals are parallelograms. So let's take a look at this first technique here. We're given that segment AB is congruent to segment CD, and segment CA is congruent to segment DB. And I'm going to prove that ABCD is a parallelogram. So all we know right now is that ABCD is a quadrilateral. We don't know it's a parallelogram. So I write down what I know. Segment AB is congruent to segment CD, and segment CA is congruent to segment DB. And then I'm going to draw a segment BC. So we can do this because a segment can be drawn between 2 points in the same plane. I should actually write in the same plane, but I don't have enough space, so we'll just forget about that. The next thing I'm going to apply reflexive property of congruence. So segment CB is congruent to segment BC. And remember, the order doesn't really matter when you're dealing with segment congruences, right? Because the definition of a segment congruence means that the measure of the lengths of the two segments are going to be equal, so it doesn't matter which direction you take it. And then I'm going to apply side postulate to statement 1, statement 2, and statement 4. And then I get triangle ABC is congruent to triangle DCB. So, like I've said in prior videos, the order really does matter when you're doing, triangle congruences. Not so much when, you're doing segment congruences, but you have to make sure they have the order correct when you're trying to establish congruence. So then by corresponding parts of congruent triangles or congruent, we can get ACB, this angle here, is congruent to angle DBC, so this angle here. Okay, so when a transversal intersects two coplanar lines, if alternate interior angles are congruent, then the lines are parallel. So if we take segment BC as the transversal, right? Well, we just showed that the alternate interior angles are congruent, right? So angle ACB and angle DBC, right? And they're both on opposite sides of this transversal, and they're in the interior region between side AC and side BD, right? So we also know that angle DCB, so this angle here, is congruent to angle ABC, and that follows from corresponding parts of congruent triangles are congruent applied to statement 5. So, and then we can use the same reasoning to establish that segment AB is parallel to segment CD. So we use the same reasoning. When a transversal intersects two coplanar lines, if alternate interior angles are congruent, then the lines are parallel. So we showed that DCB, so this angle here, is congruent to angle ABC, right? So if we take BC as the transversal, we see that these are on either side of the transversal, right? And they're in the interior region bounded by lines AB and CD. So we know that a quadrilateral that has parallel opposite sides is a parallelogram, right? So both opposite sides have to be parallel for it to be a parallelogram. So we've just shown that this quadrilateral ABCD is a parallelogram. So that's going to be our first technique. If we can show that both pairs of opposite sides are congruent in a quadrilateral, then we can establish that that quadrilateral is a parallelogram. Now let's look at a second technique. So we're given that segment AB is congruent to segment CD, and that segment AB is parallel to segment CD. So we know that this side and this side are both congruent and parallel. And then we're going to prove that ABCD is a parallelogram. Again, we start off by not knowing that ABCD is a parallelogram. It's just a quadrilateral, and we're just going to use this information to prove that it is a parallelogram. So I write down what I know, so just copy what you know here. And then I'm going to draw a segment BC. So a segment can be drawn between 2 points, right, lying in the same plane. And then I can say that if a transversal cuts two coplanar parallel lines, alternate interior angles are congruent. So we're taking BC as the transversal, right? And we know that segment AB is parallel to segment CD, so these lines are also parallel, right? So this angle, angle ABC, and this angle, DCB, are alternate interior angles, so they're congruent. I'm going to apply the reflexive property of congruence. So segment BC is congruent to itself, or segment CB. Again, the ordering is, I specifically set up the ordering so it would be more clear when we do the triangle congruence postulate, but it doesn't really matter. So we can show by side angle side using statement 1, 4, and 5 that triangle ABC is congruent to triangle DCB. So I can just I can say that corresponding parts of congruent triangles are congruent. So angle ACB, so this angle here, is going to be congruent to DBC, this angle here, right? And these are alternate interior angles, right, with segment BC, because they're both between the side AC and the side BD. They're in the interior region, and the angles are on opposite sides of the transversal. So you can use this, when a transversal cuts two coplanar lines. If alternate interior angles are congruent, then the lines are parallel. So we've just proved that segment AC is parallel to segment BD. So I use the same reasoning. So if a quadrilateral has parallel opposite sides, it is a parallelogram, right? So we've used what we know. Segment AB is parallel to segment CD, and segment AC is parallel to segment BD to establish that ABCD is a parallelogram. To be more rigorous, I mean, I just picked one pair, of opposite sides, AB and CD. You can also choose, AC and BD, and then show that it's a parallelogram, but I think you get the point. So I'm just gonna kind of go on to this next slide here. So we're given that segment OA is congruent to segment OD, and segment OC is congruent to segment OB, and we're going to prove that this quadrilateral ABCD is a parallelogram. So what does this mean with this information? Well, we know that BC and AD, these are both diagonals, right? So if we have this given information, where this point O, splits this, both of these diagonals into two congruent segments, then this is the midpoint, right? So in other words, we're going to prove if the diagonals of a quadrilateral bisect each other, then that quadrilateral is a parallelogram. So let's write what we know. We know that segment OA is congruent to segment OD. We know that segment OC is congruent to segment OB. So now I'm going to look at this angle here, angle AOC, and this angle here, angle DOB, and they're vertical angles, right? You can see that kind of like inverted V shape kind of join together at a common point, right? So we know that vertical angles are congruent. So we know that angle AOC is congruent to angle DOB. And then I can apply side angle side postulate using statement 1, statement 3, and statement 2. So we get triangle AOC is congruent to triangle DOB. Now I can use corresponding parts of congruent triangles are congruent to get segment AC is going to be congruent to segment DB, and you can just read that off, right, by the ordering in the triangle congruence AC, and then here you have DB, right? And we also know from this triangle congruence that angle CAO is going to be congruent to angle BDO, right? Well, if we look at those angles, right, we know when a transversal intersects two coplanar lines, if alternate interior angles are congruent, then the lines are parallel, right? Well, angle CAO and angle BDO are alternate interior angles, right? If you take a diagonal AD as the transversal, right, they're going to be on opposite sides of the transversal and in the interior region bounded by sides AC and side BD. So we know that segment AC is parallel to segment DB. And we're going to actually use a property that we just proved. So if a quadrilateral with one pair of opposite sides are both congruent and parallel, then that quadrilateral is a parallelogram. So actually, I'm not sure if I even said that in my last. So in this last slide, we showed that, if one pair of sides in a parallelogram are both congruent and parallel, then that quadrilateral is a parallelogram. So that's what we're using here to finish off the proof, right? We know that the segments AC and DB are congruent and that they're also parallel. So we just use what we did in our last slide to just kind of conclude that it's a parallelogram. Okay, so this is the last, I guess, technique that I'm going to do today. So we're given, we're doing this usual, we're given a quadrilateral ABCD, and we're given that angle CAB, so this angle here, is congruent to angle BDC, so this angle here, and angle ABD, so this angle up here, is congruent to angle ACD, so this angle here. And we're going to prove that ABCD is a parallelogram. In other words, if opposite angles in a quadrilateral, both pairs of opposite angles in a quadrilateral are congruent, then that quadrilateral is a parallelogram. So I write down what I know. I know these two tidbits here. And then I don't know if I actually told you guys, but the sum of measures of angles in a quadrilateral is 360 degrees. So I'm going to go over that in more detail when I start doing polygons. But just remember for right now, if you add the sums, if you add the measures of the each angle of a quadrilateral, you get 360 degrees. Now I'm going to use substitution with statement 1, statement 2, and statement 3. So in other words, we know that angle A here is congruent to angle D. So I'm just going to sub angle A with angle D. And we know that angle C is congruent to angle B. So I'm going to sub angle B into angle C. So we get this relation here. So if you add this together, then you get 2 times the measure of angle D plus 2 times the measure of angle B is equal to 360. In other words, measure of angle B plus measure of angle D is equal to 180 degrees, which is 360 divided by 2. That's just algebra. So knowing this, I can say that segment AB is parallel to segment CD. When a transversal cuts two coplanar lines, if consecutive interior angles are supplementary, the lines are parallel. So please go over my video on alternate interior angles, where I kind of derived that. So of two consecutive, interior angles. So we're gonna, and I guess in this case, we'll use side BD as a transversal, right? And then these two lines, side AB and side CD, these are going to be the lines. So this is the interior region, and when you have both angles are on the same side of the transversal and both in the interior region, then they're called consecutive interior angles. So we know that segment AB is parallel to segment CD. We also know if a transversal cuts two parallel coplanar lines, then alternate interior angles are congruent. So we know that if we use, diagonal BC as the transversal, and since we know that side AB is parallel to side CD, then angle ABC, so this angle here is going to be DCB is going to be congruent to this angle over here because these are alternate interior angles, right? And then we already know we know these facts over here in statement 1 and statement 2. I'm going to actually apply the subtraction property of congruence to statement 2 and statement 7. So we know we're given that angle ABD is congruent to angle ACD. And then I'm just gonna, subtract, statement 2 and statement 7 to get this relation here. And if I sub, what is angle ABD, this big angle, minus angle ABC, this angle, it's this angle here, right? DBC. So I just substitute. We get angle DBC is congruent to angle ACB. And if we look at angle DBC, which is this angle, and this is congruent to angle ACB, well, if we take diagonal BC as the transversal and, sides AC and side BD, then since the alternate interior angles are congruent, then these lines, segment AC and segment BD, are going to be parallel, right? So now we have established that side AB is parallel to side CD and side AC is parallel to side BD. Well, that's a definition of a parallelogram, right? A quadrilateral with parallel opposite sides is a parallelogram. So we just proved that ABCD is a parallelogram. So that's all I have for you tonight. Hope you guys enjoyed watching this video. Please go over it again. I know the proofs are pretty tough, so just hang in there. And I'm hoping it'll help you better understand, the theory that's going on. So it won't be as hard as actually just memorizing a bunch of facts about geometry. If you can derive the properties, it makes it, it's harder in the short term, but in the long term, you don't have to remember as much. So I'm hoping this will help you guys out. So don't feel discouraged. It's it's definitely hard. So I'm just hoping you guys will continue watching my videos. So I hope to see you during my next video, and I want to wish you guys a good night. All right, take care. Bye.